Well, hello everybody, welcome to the channel. My name's Tel, and today we're going to be recapping the power supply in this 1984 BBC Model B. The make of the power supply in this model that I've got is an Astec, but the mods that we'll be doing today will also be suitable for BSR power supply. So some of you may remember me trying to show you around this machine a few weeks ago, and this is what happened. Oh my god! What's blown up? The light's still on, but it's smoke. Oh, that stinks! That stinks! And as you can see, things didn't go quite the way I expected them. So, for those of you who are viewing the video where the machine actually exploded, I told you that I would order a replacement capacitor pack for the power supply, which I did. While I've been waiting for them to arrive, I did take a look around, or I wanted to take a look around, so I had to snip out that bad filter cap which exploded, which was a RIFA, with the power off of course. The carnage you can see on the screen right in the top right hand corner here. Anyway, the power supply components have now arrived, so we can get on with the job of removing the power supply and recapping it. The first thing we're going to need to do is make sure this has not been plugged in, and has not been plugged in for several hours, because what we don't want to do is get an electric shock, because this is dangerous. So if you're doing this at home, only do it if you are competent and qualified to do so. So this video is for entertainment purposes, not an instructional video. Having said that, as a disclaimer, let's get on with it. Right, so there are 7 wires coming from the power supply to the board, 3 pairs of 5 volts used to distribute the power more evenly through the board. That's the way they've done it. And you've got a purple wire down here in the bottom left hand corner, which is -5 volts. So that's easy. It's only 1 wire for that one, so we can unplug that. All the rest of them are annotated on the board with silk screen 0 or 5 volts, or VCC actually. So just take those off and this will release it. So now we're completely free of the board as far as that is concerned. You won't be able to take this power. I've loosened the screws off already. You won't be able to take this power supply out while this keyboard is screwed into place, so you'll have to take out these screws, which I already did a few minutes ago, and then we can actually remove it from the case. So just to lift it out and then just carefully place it to one side. So to get the plug out, what we can do is to feed it through here. And this kind of comes out in a bit of an odd way, really. If you put it in there first and bend it up, it comes out quite easily. So that's the power supply out, and we can remove this and put it to one side. Find a home for it for a little while, and then bring the power supply into play. Let me see if I can actually zoom up a bit more on this now. So we'll get a little bit closer. Now I don't know if that's clear enough, so let's have a look at the adjustments on here. See if I can add some more exposure to make it clearer. Hopefully that's fairly clear now. So I'll start moving this around and see if we maintain focus. Yeah, that's not bad actually. I probably won't make it any closer than that. So let's have a look around here, and I'll show you what we've got in terms of the power supply. So obviously the power lead comes in here. Let me move the camera slightly actually, because it's a little bit off center. Alright, I'm going to zoom it out a little bit actually. I'll hold it up to the camera if we need to get closer, so I'll just put it to there. Should give us a little bit of... Yeah, I think that should be okay. Hopefully I won't lose the camera. So what we've got here, obviously you've got the power lead coming in here. Here we've got a switch, a main switch. So we've got our... I don't really want to point with anything metal, although there's no power on, but I'll just be careful even though I know it's turned off. If you really want to be extra sure actually, and this is not a bad idea, put this in a bag. In fact, I'm going to put this in a bag now, or at least something that approximates a bag, so that I can't accidentally plug that in at any point. So I'm going to wrap it up and I'm going to put it over there. That way I know I can't make a mistake and plug it into the socket by accident. We need to get the board out. I'm confident on this one because this has been, as I say, unpowered for quite a while now. So there's almost no chance of any charge, but we'll still be careful. So there are 3 screws connecting the board. There's one here, there is one there, and there is one there, right underneath that earth bonding here. There is also an earth bonding here. So let's just take those out first. Let's get those out. The 3 screws. So I'm going to take these out quickly, won't take long. Stick them in there, get the 3 screws out, and then we can move on. In fact, I'm just going to tip that screw out, it's easier. And they should have these little shock proof or vibration proof washers on there as well. To get this one out here, I don't know if you can see, I'll try and hold it up to the camera. It's underneath the earth bonding, so we'll take off the earth bonding next. So there's a screw on the back here, so you can see it a bit more clearly there. So I'm going to turn it on its side, I'll just pull it out. Right, okay. The nut goes on the top of the strap here. There's 2 straps. There's also a star washer, and the star washer, and all the ones that I've seen, always goes against the case first. So the screw goes through here, and this goes on the other side of the case. So now that those 2 are out of the way, we can get the 3rd screw out. So let's do that. Always one toe, isn't there? So always one screw that doesn't want to play ball. Right, this one doesn't seem to have a shockproof washer on it, but that's probably okay because there's a star washer on there anyway. Unfortunately, the camera recording froze at this point, so I didn't actually get a shot of me taking the screw out, but it is out. Now we've got that disconnected, and in terms of the earth bond there, we need to get this one off. So let's remove that too. Don't worry if these fall off and end up in the board. All you need to do is to just shake them out afterwards. I think I got that one out, hopefully. And yeah, there was no star washer on that. Right, so here comes the interesting part. So the first thing I want to do is to remove this switch. And to remove that switch, if we look at it sideways, I'll bring it up to the camera, you can see these little leaves above the switch. So they're just above here and just below the body of the switch. They need to be depressed to push this through. So we're going to just move that mains cable out there, push that down, and it should go through. This can be a bit tricky, but you just have to keep doing it basically until it comes out. I might get the big guns out in a minute, put the big screwdriver in there if it doesn't play ball. I need to do that at the bottom as well, bit by bit. If you keep pressing it, it will come through. This power supply I think has been out before at some point in its history, because one of those capacitors looks new. Having said that, it's a bit hard to tell because it was pretty manked up. Is that a word? Manked up? Right, okay, so there we go. But I want to get these off, so I'm going to use a screwdriver and prise these off. Yeah, that one's coming off. We're kind of done with that now. All we have to do is get this out. There's a very easy way to do this, I found personally, is to use this. It looks like pure overkill, but I found it was the easiest way to do it. Squeeze it top and bottom and just push and it comes out. The difficult bit is actually jiggling it out of under here because there's not much space. So you have to kind of just tease it out gently and it'll just come out, and then the board will be removable. And there we go. I noticed there's a PAX lane bottom on here. You could take this off, but it's stuck actually. But that obviously gives you insulation between the bottom and the power supply. Right, okay. So just looking at the power supply now, this is obviously the mains entry part, and this is the main bit of the switching power supply here. You know, which is turning this on and off all the time. Yeah, this has been changed at some point actually. I'm sure that they're not normally red capacitors in there. Let's have a look at these. These don't look. I don't know if those capacitors are original or not actually. Just see if I can find a date code on there. No, I can't see a date code on it. Anyway, these big capacitors here are the ones that are high voltage and these are the ones you've got to be careful of. So I'm not using any particular protection gloves in here because I know there's no charge on it, but it's very easy to see the connections here and here and here and here, and so that's where you'd measure it if you want to be sure, but I normally just test them. That's where I took the other capacitor out from, and you can see it's got two little leads sticking through, so to get that out, as it was in a horrible condition. Amazingly, the board itself is alright, but my goodness, did it spew out some rubbish. But there's two pins there, that's its original pins, and I got this out just by getting a pair of long nose pliers in and rocking it backwards and forwards till it came out, so that's how I did it. So what we'll be doing, we'll be changing that capacitor, this capacitor, which is the filter capacitors to stop noise coming back from this power supply out onto the mains and interfering with other equipment in your house. And then we'll be changing the starter cap, which is this position here, C9, yeah, C9. These two big ones here, and then all the low voltage side over here, because we can change all these capacitors here, all of them. I haven't opened the bag with all the capacitors in, so I'm actually hoping they're all there, because I haven't really looked in and counted them at this point. So that's what we're going to do now, is to turn the soldering iron on and get this party started. So we'll start over here, and we'll take what's left of this capacitor out and this 100 nanofarad out, move on to there, take these ones out, and then move on to the rest of them. Let's put my soldering iron up to a decent temperature. I normally have it on quite high actually for this. A lot of thermal mass in the board in certain parts, so you need it to be fairly hot. So I normally have it around about 450, which is what it's on now. So I haven't got a solder sucker machine here. I just use a normal cheapo solder sucker, which is probably okay for this kind of work. So I'm just going to flip it over. I'll start with this one actually, which is the one that I've already removed a week or so ago. The only trouble with these solder suckers is that they leave a lot of mess everywhere, which is not desirable really. But if you're not doing a lot of desoldering, then it's okay. If you're having to actually take out 15 chips on a motherboard, then it's a problem. So there's the two little legs. Worth checking that they've come out, because you don't want them floating around on the board, and they've come free. So the other one is this one. These you don't have to worry about polarity because they're not polarized, not like the electrolytics. So there's zinc, these two filter caps, I believe there's zinc coated paper, and what happens is if they're left in a damp environment, they absorb moisture. Eventually that moisture gets into the paper and creates a short, and you get high energy burst and it blows it to pieces. So there's that one. This looks fairly new actually. I can see some cracks forming, but not that bad, but I'll change it anyway. It's not worth the risk. Just not worth the risk. So we'll take the little red one out there, which is C9, but we will see if I'm right in a minute. Yeah, I am right. It is the right pins. Yeah, I just don't know how long ago these would have been changed. I don't know. I thought this has been up in the roof for ages. She's nearly out. Right, the big ones are folded over. Their pins are folded over. I just noticed actually, I don't know if you can see it on there, if it's light enough. Yeah, you can see there's a little plus sign there. So on these capacitors, electrolytic capacitors, these negative symbols along one end means that's negative. That goes to the negative voltage, and that plus obviously is the opposite. That's the plus voltage, and you'll find these on all of these. There'll be a marker on the board annotated to show you how it goes back with the number of the capacitor on it as well. So it shouldn't really ever be a problem. These ones just need teasing up a little bit. Just remove some of this solder. These are quite big thick pins on here, so sort of seems to require a bit of extra. Yeah, you're really better off if you can get hold of a soldering machine, to be honest. But I should really get one. But I've heard that the only ones worth of getting are the expensive ones. So I don't know if that's true, but I don't want to spend a lot of money on them. So I'm not soldering all day long. Lots of joints. So there she lays. So I wonder if I can get a bit more insight into this now. No, there's no date code on there. Yeah, so these are rated at 250 volts, 100 microfarad each. So we take the other one off as well. And now we're developing a nice pile of solder. Yeah, do you know what? Have a look at that. Check this out. Can you see all that gunge around the bottom, near the bottom of the transformer down there? That has gone in the past. I believe this one has gone in the past. This cap, and they replaced it, but they didn't replace that one. I need to clean that out. The thing about these capacitors is these, because they're zinc coated, obviously, you know, capacitor plates are going to be conductive because that's the nature of them. But when they come out, if one blows really badly, it can sometimes infuse itself into the board and you know, short out other components. So that's one to be careful for. If you see a silvery sheen on the board, then you should get that scraped off. You test it with your multimeter, you'll find that it's conductive if it's near one of those RIFA caps. So I'm just going to carry on now. I'm going to remove other ones here, which is going to take a little while, so I'll be speeding it up. Okay, so that's all the capacitors taken out and ready to be populated with new ones. So I'm just going to pause the video for a moment while I sort out this mat, which has become infused with solder rather horribly. We'll get that cleaned up. I'll just give this a little brush first and put it to one side. Alright then. So I'm going to open the bag with the capacitors that came and we'll fit them to the board. Turn on the soldering iron and away we go. Right. Alright folks, before we go forward, I've sped things up a little bit by already inserting some of the capacitors shown by the yellow arrows. You can see top right hand corner and bottom right hand corner there's still two caps to do. So we'll pick those two up now and finish that off. So yeah, so I put C16, C19 and 20 in. I'm just going to solder those in now. 1000 microfarads each for their trouble. Do you know what? When I start these jobs, I always think it's going to be quicker than it actually is. So in my mind, I've got a figure of like 30 minutes or something to complete a job like this. But it almost always takes longer. There's always little niggles, little problems. Can't get a screw out, can't get a screw in. That just blows your estimate of the time it takes to do a job. But I guess that's just life, isn't it? That's the way it goes. So that's all those done. And now there's two left. So it's C17, which is a 2200, which is that one. That's C17, and the plus goes to the top, so negative to the bottom. And finally, this little one here, which is 10 microfarad, C21. No, sorry, that's a 220, I beg your pardon. Okay, and the plus is to the top, so negatives to the bottom. And that is it, that is the last one. So let's spread those caps, spread them baby. Spread them so we can solder them properly. I'm just pressing these down in so they're nice and flat on the board. Right, so they're all nice and flat now. Just want to get this little 220 microfarad dialed in. And we need to give the board a really good clean up. So, liberal amounts of isopropyl alcohol. Hopefully that should be it in terms of the capacitors being soldered in. Now I think we just need to check the board itself. I'm going to zoom in a bit more. So let's have a look. Are there any bridges or any shorts? I'm just going to bring down my magnifying glass for really close work. I don't know how this is going to work, but it's going to give us a better... that's not too bad, I suppose. Right, so what I'm looking for now is any dry joints, clear around things like the transformer legs. But I think they look all good. I can't see any bridges between any tracks. Yeah, it looks okay to me. I'm actually going to get some new camera equipment soon, which is going to be ceiling mounted. So that's going to make it a lot easier, I think. So I think that being done, there's only one thing to do really, and that's to put it all back. So let's get on and do that. Let me just check this switch. The contacts go at the bottom like this, and this is in the off position, I believe, because it turns, it's off when that's pressed. Yeah, that's in the off position. But let me just check that. So there's no contact between those on those side. It is on all on the one side. These are the. Oops, that was me just touching the other one. So that's off, and that's on. That's on. That's on. These don't get any contact with each other. It's only the top and bottom ones. Just to double check on that. Just to make sure. Right, so I'm going to put the neutral that's coming in from the power there. And the live there. And that means we need the black one going into the power supply there. And we need the red one going in there. So the red will be connected to brown, which is good, and the black will be connected to blue, which is also good. And then we need to squeeze these in, and that will just snap into place. And these might need a bit of teasing around to get them positioned right, and check that these lugs, you could check if you want to see these lugs have engaged, and they have. But for the avoidance of any doubt, I'm just going to make sure they've clicked out, which they have. And you can't push that out now, so that is correct. That is as it should be. Now the most awkward one is going to be the bonding, the earth bonding here. It's a real pain in the posterior, I could say. And I also think that we need to just lever these little connectors up a little bit, because the board's not sitting in the right position. Okay, so I'm going to put one of these screws back in just to give it a position. So that's one, and I'll put another one in, and that will go over there, so get that one in position as well. I don't know whether it'll hold the little washer, because this it's magnetised. It does actually, just about. That's good. It just dropped as I put it in. That would have been annoying. Okay, so that's in. Right. The next thing to do, I think, would be to put this earth bonding on. This is my most hated part, I think, of doing this. But it's got to be done, boys. It's got to be done. Got to have your earth bonding on. Right, I'm just following what they were before, which was the star washer up against the case. So this is also a pain. That the back connector, which supplies the power supply here for the disc or any auxiliary stuff, is very close. It's just a nuisance. Right, at last, he said. At last, at last, at last. So the earth bonding at the rear one is now in position. What I need to do is try and find a way of getting that nut on there. And the inevitable happens, and I drop it on the floor. Fantastic. Right, that was really, really good. I'm so pleased that happened. Where did you go, oh nut? Right, the good news is I found it. So all's well. All I have to do is get it on there now, which is the tricky bit. I'll find reversing the screw to begin with helps locate it on the top, and then you can get it in. Just going to put my big grips in there. Big grips. Right, so this one, which is the other earth bonding screw, and do what was there before. The star washer was on the inside. Again, reverse into thread, and then coming back for the kill. Before we do this, I just realised I forgot to put the final screw in. God damn it. Right, so here we go. The final board screw. It's the final board screw. Just one last job to do in terms of the main part of the reassembly, and that is to push this little baby back through the hole, and it should be easy as pie. And there you go. Just test it to make sure it is snapped in, which it is, and you can't push it back in. So everything, let's check everything. Earth bondage, earth bondage, earth bondage, all nice and tight. Blue to black, red to brown. This is supposed to have, I think this is supposed to have a something holding these on, these leads, but to be honest with you, I'm not sure whether that's where that's supposed to go, so I'm just going to push it through there, which is the only aperture that I can see at the moment. And I think the reason for that, in all likelihood, is to stop that pair of mains cables getting trapped in that screw or touching that screw. So I don't know, I'm guessing. So I'm just going to put it there, and then I believe this needs to be secured to here to give you some, so we'll just secure that to this body so it's not going to float around anywhere that we don't want it to. And I believe that that is done. There are a couple of things we could do. We could test it out of circuit, which is going to be okay. So I think what I'll do is I think I will put it back in the machine for safety's sake before we turn it on. I think that is the right and proper thing to do, but we can put a load test on it, so I think that's what we'll do, or at least test the voltage before we plug the board in. We definitely want to test the voltage before we plug the board in, that is an absolute certainty. Right, so there's just one more test that I want to do, even though I know it's been wired correctly, but for safety's sake, there's two more tests I need to do actually. Let's just do it. First of all, I want to make sure that we got a good connection between the earth plug. So on here, hang on a minute, let me take a relative meter. Right, okay, so if I take a relative reading, 0.2 of an ohm between the earth and there. Okay, then I want to check that the live pin, and the live pin is this one, goes to the fuse. So that's switched. If I turn it off, it's off, which by default must mean that the neutral pin, which is there, okay, is connected to the blue, which it is. So I just wanted to double check that and make sure that this earth bonding was okay and the right pins were connected to the right terminals, so these weren't swapped, in other words. So that all looks fine. I've also tucked this green wire down here, so that's out of the way. I'm not gonna actually put a tie wrap on it. I don't think I need to do that, but it's out of the way, so it's not going to float around the board. These are all tied up here now, and this one just is what it is. It's always in that position, just sitting there, so that's fine. Shouldn't be a problem there. And that's it. Right, so let's get on with it. So before we plug anything into the board, what I'll do is plug the meter lead into the 5-volt supply output. Check that first, and if that's okay, we'll test the -5 volts. Check that, make sure that's okay, and if that's alright, then we can plug it all back into the board and go with it. Just make sure we haven't got some silly voltage on there. So these leads are not touching anything, these leads are free over here, and these leads are just plugged straight in. So I'm just going to turn it on. And we have, this is unloaded, right? So 5.099 volts. So the 5 volts is good. and we'll check the minus 5 volts, which probably will be sitting around minus 4.67 or something like that. 4.4, right, okay, which is fine. So I'm going to turn this off, and we're going to plug these in. But I'll plug in that, I'll just plug in that one minus 5 volts. Yeah, okay. So let me plug in the other ones now. So these go, actually easy to remember, these go black, red, in other words black on the left, red on the right for the first two positions, but you should check this anyway. And then over here, the red is on the left, so that's the VCC there. So that's 0 volts, that's 0 volts, that's 0 volts, the rest of them are just red. So if we hear a beep boop or boop beep, then we know this power supply is working. Don't know if you heard that, that's very faint actually. Maybe I can try and adjust the little potentiometer. There's a little potentiometer in here, which probably somebody's turned down, I expect. So if I do a Control G, there we go. It's a bit louder, isn't it? So what I'll do is I'll gather together some links for the video description that will have things like places you can get capacitor kits from, and also if I can find decent circuit diagrams online, I'll put a link to those as well. So I really hope that you found the video interesting and useful. If you did, please hit the like button and hopefully the subscribe button if you're not already subscribed, and I'll see you next time.